Hello students, welcome to MGC Learning. I am Manju Dilip. Today I am going to start with the 12th standard mathematics topic, probability distribution, part 1. So in this chapter, I am going to discuss random variable, types of random variables, probability distribution of random variables, and discrete random variable, and solving some exercise questions. So we'll discuss random variable. The definition of random variable is a random variable is a real valued function defined on the sample space of random experiment. In other words, the domain of a random variable is the sample space of a random experiment. So a domain is the sample space and its range codomain is the set of all real numbers that you have to remember. So we can write random variable x from S to R is a random variable. So it's a function x from sample space S to the real numbers that you have to remember. So example, first one, experiment of tossing a coin, then the sample space is set H to T and the codomain of corresponding will come as the real variables. Real numbers. So experiment of tossing a coin until a head is obtained. The sample space for this experiment is H, T, H, 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 T, so T, 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 H, T, 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 H, etc. So last term, etc. means this is infinitely it is going. That kind of sample space you will get, and the corresponding values of this will be real variables in the codomain. Real numbers in codomain. Types of random variables. So there are two types of random variables. First one is discrete random variable and another one is continuous random variable. So we are going to discuss discrete random variable and continuous random variable in this one. Under that we will discuss different topics in each of this category, discrete and as well as continuous. So first one, discrete random variable. A random variable is said to be a discrete random variable if the number of its possible values is finite or countably infinite. So its number of possible outcome will be finite or countably infinite. Then it is called a discrete random variable. So the values of discrete random variable are usually denoted by non-negative integers, that is set 0, 1, 2, 3, etc. For example, the number of children in a family. That is countable definitely. We can count it properly with your fingers. The number of patients in a hospital ward. That is also countable. The number of cars sold by a dealer. Again that you can count it. Number of stars in the sky. That is infinitely but countably infinite category, and so on. Continuous random variable. A random variable is said to be continuous random variable if the possible values of this random variable form an interval of real numbers. So if it is the real numbers in between 0 to 1, closed interval 0 to 1, then definitely that kind of functions will come, random variable will come as continuous. So continuous random variable has uncountably infinite possible values. In discrete random variable, it is countably infinite, but here it is uncountably infinite possible values, and these values form an interval of real numbers. For example, height of trees in a forest. So to calculate this one, you want some measurement gadget. Similarly, weights of students in class, weighing machine you have to use. Daily temperature of a city, again you have to use some gadget for this one. Speed of a vehicle, also speedometer and so on. So in all these cases, we have to calculate this way some measurement method. So the value of a continuous random variable is obtained by measurement. This value can be measured to any degree of accuracy depending on the unit of measurement. This measurement can be represented by a point in an interval of real numbers. So it will lie definitely in real number system and inside some interval. That is why this is called continuous random variable. Infinitely uncountably infinite possible values will come in the range set. So this kind of function is called continuous random variable. Probability distribution of discrete random variables. Now, what is this probability distribution? We have a probability distribution of discrete random variable as well as probability distribution of continuous random variable. So probability distribution of discrete random variable is the probability random variable we will consider as x, and it is defined in the following number of systems. Let the possible values of x be denoted by x1, x2, etc., x3, etc., and the corresponding probabilities be denoted by p1, p2, p3, etc., where pi is equal to capital P of x is equal to xi. Either you can represent these probabilities as pi generally for I equal to 1 to 3, etc. So instead of writing p1, p2, p3, etc., we can simply write pi, that's equal to probability of capital X is equal to small letter xi. And we can write for I is equal to 1 to 3, etc. for instead of writing this way. Similarly, corresponding x1 we are getting some probability like this. This probability distribution can be written in two ways. Either you can write for x1 there is probability p1, for x2 p2. So each one we will represent with the ordered pair method, otherwise tabular form like this. So xy's we can write in the first row and probabilities we can write in the second row. This way also you can represent. So discrete random variable can have finite or infinite number of possible values, but they are countable. It must be countable. So these are the two ways of representing probability distribution of discrete random variable. Probability mass function. What is probability mass function? If the possible values of discrete random variable x be denoted by x1, x2, etc., and the corresponding probabilities are pi and can be written as probability of x is equal to xi for I equal to 1, 2, 3, etc. If there is a function f such that first case, all the probabilities, pi, that means probability of x is equal to xi, that is f of xi, is greater than 0 for all possible values of I. That means all the probabilities must be non-negative. Second condition must be summation of all the probabilities. Summation of pi is equal to 1 means all the probability given in the question, if you are adding, you must get 1. That is the total probability. Then f is called the probability mass function. So whatever the function given in the question, you have to check both this condition. All the probabilities are greater than 0, then first condition satisfied, and you have to add all the probabilities given in the question. If you are getting 1, then both the conditions are satisfied, therefore the given function is the probability mass function. If either of this condition is not satisfied, if one of the probability is less than 0, then you don't want to check the second condition. First condition is not satisfied, therefore the given function is not a probability mass function, you can write. Or if first function is satisfied and second condition, if you are not getting 1, exactly 1, sometimes you will get 0.995 or 1.01, etc., which is not equal to 1 but below a 1 or above 1, that case you will consider the second condition is not correct. So that time the given function is not a probability mass function. State which of the following are not probability mass function of random variable. Give reasons of your answers. So the first question is x is the table is given here, x 0, 1, 2, probability of x is 0.4, 0.4 and 0.2. If the given function is a probability mass function, we have to check all pi values are positive. So here you can see first value 0.4 is greater than 0, 0.4 here again, all the pi's are greater than 0. So first condition is satisfied, here pi greater than 0 for all I. Second condition, summation of all probabilities, that means 0.4 plus 0.4 plus 0.2, that's equal to 1. So second condition is also satisfied, therefore the given function is a probability mass function. But that is not the question, you have to check the following. In the following questions, which are the functions are not probability mass function. So this question is not a that category, this is probability mass function. Second question is, here you can see the table. All the probabilities are not, probability are given are not greater than 0. For x is equal to 3, minus 0.1 is visible. So the first condition is satisfied, not satisfied. So not greater than, that means not greater than 0 means what? It is not, all the values are not greater than 0. Only for x is equal to 3 we can see P3. Actually P3 is less than 0. So second condition you don't want to check it because it is not satisfying. Therefore the given function is not a probability mass function. Next question is, table is given here. The given function is a probability mass function. We have to check all the PI's are greater than 0. Here 0.1, 0.6, 0.3, all the three functions are greater than 0 for all I. And summation of this one, 0.1 plus 0.6, 0.7 plus 0.3, that is equal to 1. So both the conditions are satisfied. So the given function is a probability mass function. Next question. Here all the probabilities are greater than 0 for all I. Greater than 0, sometimes equality will come, but if we are considering Pi greater than or equal to 0, then this is satisfied. Otherwise you have to check both the conditions. So 0.3 plus 0.2 plus 0.4 plus 0.05 is 0.95, which is not equal to 1. Therefore both the conditions are not satisfied. Therefore the given function is not a probability mass function. Now some exercise questions are given to you. You have to solve it. Thank you.